This is the homework helper for Chapter 9, Section 5 in the 8th grade workbook, Variability. So let's start with number 1. You'll do the same thing in number 2. You're making a box and whisker plot. So as you saw in the note instruction, because the box and whisker plot involves medians quite a bit, you're going to go ahead and start off and put the numbers in order from least to greatest. So let's go ahead and put these numbers in order here. We've got 36, and then we've got 43, 45, 46, 52, 55, 61, and 70. Alright, so now what I want to do is go ahead and identify the middle number on the list. Well, I have two middle numbers here as I counted from the outside to spot my middle number here. 46 and 52 are my two middle numbers. So remember, when you have multiple middle numbers, you're going to average them, as we saw in the definitions when we were talking about mean, median, mode, and range. So what's between 46 and 52? Well, that number that's going to be in between is 49. So my one median here is 49. Now, the median is going to separate your numbers into two lists of numbers. So you've got everything smaller is its own list, everything bigger is its own list. I'm going to take those lists now and find the medians here. So between 43 and 45 is 44. Between 55 and 61 is 58. Again, you can add those up and divide by 2, or you can just figure out the number that's perfectly in between. Either way gets the job done. 43 and 45 should have been an easy one because it's just simply logical number order. 43, 44, 45. On the big side, that might have been a little more thought. 55 and 61, that's a gap of 6. If I chop the gap of 6 in half, that's 3. Add 3 on or subtract 3, whichever way you want to look at it. 55 plus 3 is 58. 61 minus 3 is 58. That's the number that's perfectly in between. Alright, so I'm going to go ahead and fill in my number line here. As you can see, they've given me a number line to use here. I'm going to make my number lines go by 2s here just because I can. I need to cover the gap from 36 to 70 here, and I'm hoping I just have enough lines to do that. And it looks like it's going to be close, but I think I'm going to have just barely enough, or I might have to add on one little line or two. Not a big deal. Okay, there we go. Alright, so now remember, when we make a box and whisker plot, our three medians, the median of the whole list and then the first and third quartile, get boxed in on the box and whisker plot. So I'm going to put one part of the box at 44, another part of the box at 49, and another part of the box at 58. And I'm going to encapsulate those to make the box of the box and whisker plot. As far as the whiskers go, the whiskers connect out using dots. The whiskers go to the smallest and the biggest number on my list, which in this case is 36 and 70. So a dot at 36 and a dot at 70, and draw lines out from the box to those big and small numbers, and you've now made a box and whisker plot. We'll also take a look here at number 3. Number 3 is asking me to use the interquartile range to identify outliers here. So if I'm finding the interquartile range, I'm really doing all the work for box and whisker plot, but I'm not actually making a box and whisker plot. So let's go ahead and set it up though. Got to put the numbers in order first, so that's where we'll start here. We could see, kind of looking at this list, what the outlier might be, because we've got all these numbers in the hundreds, and then all of a sudden 85 is there. So we might suggest, just looking at the numbers here, that 85 might be an outlier here. And as I keep putting these numbers in order here, I'm going to see another number here that might be an outlier. Maybe even 2, because as you can see on the big end here, I've got 182, and most of these numbers are in that 110, 120 area. This might be an outlier. 182 is really big compared to most of these numbers. That might be an outlier. 136 might even be an outlier here. Compared to a lot of these numbers here in that 110 range, that looks kind of big. So we might have a few outliers here. We'll see here what happens. So we're going to go ahead and find the median here. That's how we start, by finding when we're creating a box and whisker plot. We have 7 numbers on this list, so my 4th number is my median, so that's 116. All right, now from that, we separate our list into 2 parts. Everything less than the median is its own little list. Everything bigger than the median is its own little list. And you find your other 2 medians, which are called the first and the third quartile. So that's going to be your 112 and your 136 here. So now we know our interquartile range. The boxed-in region, if I was making the plot, would be 112 to 116 to 136. The interquartile range, then, is what we get when we take and subtract off 136 and 112. 136 minus 112 is 24. So the IQR here, the interquartile range, is 24. Now remember, based on the formula, we said that now we're going to take that interquartile range and multiply it by 1.5. Well, I'm here to tell you, when I take 24 multiplied by 1.5, that's 36. So anything that's more than 36 jumps away from the box is outside of the acceptable range and would then be an outlier. So on the big end, the box ends at 136. Well, if I add 36 to that, 136 and 36 makes 172. So anything that's bigger than 172 is outside of the acceptable range mathematically. So 182 is indeed too big. It's an outlier. Now as we come down to the small side of the box, 112 is that. Anything more than 36 away again from 112 is unacceptable. So if I take 112 and subtract 36, I end up with 76. So 76, anything less than 76 is going to be too small. Well, 85, that actually did fit. All right, it looked like maybe just looking at the numbers it didn't, but mathematically it worked. It was actually well inside the range. It wasn't even really that close to 76. So the only outlier mathematically ends up being 182. Again, take your interquartile range, in this case 136 and 112, subtract, and then multiply by 1.5. 1.5 is how you always find this. It's not why is it 1.5, it's not why isn't it 1.4, it's always 1.5 mathematically. All right? That's going to tell you how far away a number can be and still be acceptable. Anything that's outside of that area, again, we're talking units away from the ends of the box, so 136 plus 36 and 112 minus 36, anything outside of that area is considered to be an outlier.